Recording in the cloud. All right. Welcome, everybody. This is Houston.NET User Group, the Greater Houston Area edition, meeting number 212. Welcome to this lovely Thursday evening. Welcome to our friends from the North Houston.NET User Group as well, all over Houston. We welcome all Houstonites and the one person from Ohio. Today's meeting is sponsored by Couchbase. We'll hear a little more from them afterwards. And let's get started with some administrative goodies. We're going to talk about the agenda as usual. We're going to have some announcements. We're going to have some prizes. We're going to have a word from our sponsor, Couchbase, who's here. We've got, we have 2 licenses to give away for JetBrains, which we will. And Couchbase also has a delicious prize to raffle off too. And then Matthew Groves will regale us with tales about NoSQL data modeling. And he will teach you how to make all that money you need in NoSQL. No, that wasn't part of it? Okay, maybe it was.
I can try.
Try. Do or do not. There is no try. Wireless, hey man, you're connected to it. You're already there. This is great. Nothing to do there. Restrooms, feel free to use them. The break room, lots of snacks. Help yourselves as much as you want. You know, we're here for you guys. So if you feel like, man, you got to get a snack from the snack place, it's all there. It's fully stocked. There's probably some adult beverages, some non-adult beverages, salty snacks, sweet snacks, whatever you got. So yeah, there's that. We are part of the, there we go, start over. We are part of the .NET Foundation Meetups, which meems that our meetups and events show up in the list of all the .NET events that are going on. If you haven't heard of .NET Foundation, you should go in there and take a look. They just recently are updating the mission statement. They got new officers in. They're supporting open source projects. They're supporting a lot of conferences and things that are going on. And they're supporting the mission of setting up the .NET ecosystem and helping people to be able to get into .NET, to use it effectively, and talk about it like we are doing today. .NET Conf. So more .NET news. So .NET is a free conference. If you haven't heard, next month, .NET 5 is going to launch, and this conference is going to be full of delicious information about it. All the cool new stuff going on, a lot of libraries, the demos, Microsoft, other people, everybody. It's going to be November 10 to 12. I took the screenshot a few days ago, so the date is wrong, but the date is correct. So make sure you head on over to .NET Conf and sign up. And it's free. If you don't catch it live, they'll have recordings, and you can always watch it after the fact. It's a great conference to get to know some of the new technologies that are coming out there and to get a feel for how .NET 5 is going to be changing how we work with .NET as we go forward. I know that we're looking at this a lot as well because we have clients that are or they're on .NET Core and they want to figure out, well, what do I do? Where do I go? Where do I upgrade? So it's going to be fun stuff ahead there. So make sure you don't miss that one. In other news, you can connect with us on Facebook, LinkedIn, and Meetup, and Twitter as well. This will be recorded. It is being recorded. And it will be posted on YouTube. I'll put the link into the Meetup comments whenever it finishes rendering and finishes uploading and all the goodies that it needs to do to process video. And that'll be there as well. Also, our friends at the North Houston.NET User Group, they have their website, hnutnug.org, Twitter, GitHub, Facebook, also very accessible, and reach out to both of our groups if you want to talk about stuff or questions and comments. Other companies hiring, Improving has some stuff on their site. Catapult, I think, had some as well. We were plugging iSphere for North Houston User Group, but their job site went down yesterday, so I'm not sure if there's no opportunities there or not. So if you are also a company who's looking for developers who are of the .NET persuasion, you're in the right place. Plug some info in the Meetup or in the comments here, and just watch the resumes come rolling in. There's one right there, couchbase.com/careers. Shameless plug, but I'm okay with that. I'm okay with that because it's helping everybody out. So if you are a company and you're hiring .NET developers, this is the place for it. You can hook up with us on LinkedIn as well. I'm connected to a bunch of recruiters, and a bunch of us are all connected to recruiters. So reach on out and see what happens. I know oil and gas is having some challenges, but hopefully we can find everybody a good place to go. So Couchbase is sponsoring this month's meeting, virtual as it is. And Nick is going to regale us as well with some tales about Couchbase.
Awesome. Thank you, Garo, and thank you to the .NET Users Group for having us here. We're excited to get to know everybody. Myself, I'm one of the account executives based here in Houston, and on the line with us as well as Brian Kane, who's also based here in Houston, who is our solutions engineer for our customer base and people that we work with here. And then we have Matt Groves, who is our senior developer advocate, and he's going to have most of the time today. I'm going to make this part really brief as this is a technical conference. Just wanted to give you guys a quick background of Couchbase, who we are, what we do, and who's using Couchbase out there, really. Yeah, Garo, if we go to the next slide, that'd be great. Next. Right. So, we are a NoSQL database, and we're going to get into, what makes us different or unique from some of the other ones, as Matt's, going through data modeling with the document database, specifically JSON. But, we were founded in 2011, had some very good growth. We have a very high customer retention rate, and there's several reasons for that, but we can kind of get into that later. We've got great backing behind us. So a lot of these guys that have invested in other Silicon Valley companies really believe in us from the get-go, seeing that what we're doing as an enterprise NoSQL database platform is a little bit different and unique than what other people are doing, and the way that we've made it easier for developers to make that transition from the RDBMS world into kind of the NoSQL world, especially as we're dealing with IoT and mobile applications and on and on. So I just kind of wanted to throw that out there. And then, Garo, if we could go next.
Can.
Yeah. And so here, just wanted to throw this quick little slide in here. These are some of the trusted companies that are using us, and they each have unique applications and what they're using Couchbase for. I think this gives, a little bit of color on the trust and who's using Couchbase, and they've been using us for a while now. A lot of it, if you see some of the stats there, it boils down to high throughput, low latency, lots of transactions across, using mobile applications, multi-cloud strategy, and then very low minimal response times and very high transactions. So that's a little bit about how we perform. And then the next slide. And then again, you can see here that there's obviously some really well-known names here across multiple verticals. I mean, everything from retail e-commerce and financial services. We've got oil and gas here locally. It's not really listed on here, but folks such as Baker Hughes, EOG, and so on are using us. So, it's the flexibility of, what we're going to discuss today, what Matt's going to go through, and this gives us a lot of credibility. So I hope that gives some good background who we are as a company. And as I mentioned, this is a technical meeting, and let's leave it at that. And if anybody has any follow-up questions, feel free to reach out to any of us here at Couchbase regarding the technical aspects, who we are as a company, or if you want to test Couchbase, try it out. We make that available as well. So with that, I'll leave it with that. And thanks again for having us.
Cool. I saw Matt had said that there's some open positions. What kind of jobs are you hiring for?
I mean, we have a lot of different positions open, a lot of different type of positions open for technical people, for developers. So some positions are like solutions engineers. We've got some technical support positions. There's a lot of hiring on our cloud team. Our new cloud offering is hiring as well. So there's a lot of variety there, and new stuff getting posted all the time. So we've we've been trying to hire like crazy this year. Despite of all the unpleasantness, we're still trying to hire lots and lots of people. So definitely check it out. See what positions are there. Anything interests you, reach out to one of us. Happy to talk to you more about it, or forward you on to someone from HR who actually knows more details than us. So.
Perfect. If you check in the chat, Lindsay from Couchbase has posted a message. They're going to be having a raffle for a Raspberry Pi 8GB starter kit. So if you're interested in entering that prize raffle, send a direct message using the chat to Lindsay. So what you'll do is on the 2, you'll pull it down. You'll find Lindsay. There's only one Lindsay, so that's the right one. And send her your full name, company, email address, and she'll put you in a running for the drawing, and then they'll contact you if you win. All right. Oh, there it is. That's what I meant to say. So find Lindsay, let her know, give her all of your personal information, credit card numbers, they like that too. Personal identification, whatever it takes to get that Raspberry Pi. Sell your soul if you need to, because it's great stuff. And you can run Couchbase on a Raspberry Pi?
You can certainly run, I believe, Couchbase Lite on Raspberry Pi, which is our mobile or what we're calling Edge offering now. I think some people have compiled Couchbase Server to run on the Raspberry Pi. It's a little more challenging because we don't have an official ARM distribution, at least not yet.
Cool, good to know. I think you'll be collecting names through the presentation and then contact afterwards. So it doesn't have to be immediately, but don't forget. Also, we're giving away 2 JetBrains licenses. So I will figure out how many people we got here. We got 17, 16 not counting me. So 1, 2, 3, 4, 5, 6, 7, 11, 12, 13, 14, 15, 17. And we will pop up a browser window and use, as I like to use, the North Houston.NET user group handy dandy raffle clicker. All right, let's find out where that is. Move all these things around. So we will pick, after I shuffle this around. There we go. 1, 2, 16. And so number 1, 9. 1, 2, 3, 7, 8, 9. Lindsay wins JetBrains.
It won't be unwasted on me at all.
And 13. Miguel Rodriguez. I will get in touch with you and send you the goodies. But Lindsay, you want JetBrains, right?
Of course I do.
Excellent. It will be yours. All right. I'll message you guys. Send me your email to private message, and I will send you the details and tell you about how you can redeem the JetBrains license for yourself. And make sure you use it in a timely manner because it does expire, like milk, not like wine. All right. And without further ado, we're going to have Matthew Groves to talk about JSON data modeling in document databases. I will pass you all of the powers and privileges of presenting. Right. And the floor is yours.
All right. Can you see my screen okay?
Yes.
All right. Excellent. So thank you very much for introduction there. And I will also say that if you have a JetBrains license, you should definitely check out DataGrip, which has just announced Couchbase beta support right now. So a great choice there in JetBrains tools. So we're talking about data modeling today. Most developers are probably already familiar with the relational way of modeling data shown here. But if you want the benefits of a non-relational database, you kind of have to think differently about modeling. So I usually like to plug the group I'm at just in case there's a recording later. Sounds like that's already been covered, but the last time I was at the Houston.NET user group was back in 2016, like pretty much 4 years ago to the day, I think. I'm just wondering if anyone remembers that, because I remember it was it was a blast. It was a really energetic group, and I wish I could be there in person this time. Maybe next year. But if you're watching this recording elsewhere, make sure to get yourself to an HDNUG or a North HDNUG meeting, because it is a great group and lots of fun. I'm Matthew Groves. I'm a developer advocate for Couchbase. There's my Twitter information, my podcast and blog. Just a quick plug, by the way, Garo, since I know you've been involved in this in the past, the C# Advent is coming up very soon. So you might want to keep your eye on that blog there for more information about that, if you want to participate or if you just want to check it out. I'm an MVP, a Pluralsight author, Manning author, blah, blah, blah. That picture kind of looks like me, if you squint a little bit. Back when I used to wear ties and leave the house, I guess. All right, so JSON data modeling, what we're talking about today. This is what I want to cover. We're going to spend a little bit of time on the why NoSQL. We're going to talk about how modeling is different in JSON compared to relational. And we're going to talk about accessing data and how that figures into modeling, because that's a very important part of it as well. And migrating data and migrating/syncing data from relational to NoSQL or vice versa. And then feel free to stop me anytime with questions. Garo has said he will interrupt me, which is totally fine. And I don't know if I can really look at the chat here. I'll try my best to monitor the chat, but
I'll keep an eye on it. I'll let you know. Yeah, I'll be watching the chat. If there's anyone that wants to interrupt and ask, just unmute yourself and ask a question. And then please mute yourself afterwards. And then I'll be watching the chat if you just want to type a question, and I will interrupt Matt as much as I can and let him know.
Sounds good to me. All right. So why NoSQL? Because we know relational databases are really great. They give you lots of functionality, a great set of abstractions. We understand, how tables and constraints and triggers and all those great things work. But the thing I want to focus on today is that change is inevitable. And one thing relational doesn't handle very well, in my experience anyway, is change. And we're talking about change of schema mainly today, but also change of capacity, change of hardware. And so NoSQL databases, especially those that are designed to be distributed, tend to help solve problems with agility, scalability, performance, and availability. I'm hearing some typing going on here. Is someone not muted, or is that okay? Just want to make sure. Okay. All right. So let's talk about what NoSQL is first. So it generally refers to databases which, historically, that lack SQL or don't use a relational model. So once the SQL language itself becomes optional, you get a flurry of other database approaches, other approaches to storing data for common use cases. So key value is how you look up data just by a given key. We're going to talk about that a little bit today. Wide column, you can store a large number of columns in each row, sort of in a flexible way. You don't have to define them up front. Graph databases are very cool. You can store data and relationships as first-class concepts. But a document database is what I want to focus on today. And it's basically like a key value database, except that the data is in a specific format. So we're talking JSON today, but it could also be other formats, less commonly like XML, for instance. And there might be a YAML database out there. Let's hope not, but there might be, I don't know. But any sort of format like that can be a document database. And going back to that NoSQL keyword, this is kind of the original set of operations you would use to interact with a database like this. So you access things by keys, and then you could actually map the data out. Because it's JSON, you could parse it out, you could map it and reduce it. And that's just kind of the minimal set for document. And it's changed a lot since then, a lot since those very early days in NoSQL. But that's kind of where that buzzword comes from. So again, think of a document database as kind of the simplest as a key value store where the value is a known format. So you write code where you start with a key, you ask the database to return that document, and that corresponds to that key. And it's the same thing as with creating and updating. You say, I want to update the data at this key, and it goes and does it. So why does NoSQL exist? What are the benefits of it in the first place? Why do people even attempt to take this on? Well, one of the reasons is scalability. And so it's a distributed database, which means that it's not designed just to run on one server alone. It's meant to run on multiple servers together in what's called a cluster. And it's distributing the data amongst those nodes via the network. And so what you can do now is if you have multiple machines, you can keep adding machines to it to increase your capacity. And this is called horizontal scaling or scaling out. And you can do this with commodity hardware. You don't need to buy the big expensive, 128 core machines or whatever to handle, millions of operations, for instance. And this is especially helpful if you're on the cloud. You can just keep adding more and more VMs if you want to. Or let's say you're in a seasonal business like a retail or something. You don't need as much capacity. You can actually scale back down, save some money on the hardware, the VMs, or whatever. And so flexibility, I already mentioned this. Schema flexibility is what people mostly think of, which means you don't have to define a schema up front. It helps to model data, as we're going to see, but you don't have to enforce that in your database. And this allows you to more quickly respond to business requirement changes and changing the structure of the data. Mentioned before the session that IoT, for instance, or pulling, integrating data from multiple sources, and that flexibility really helps you to ingest data. So if any part of the data that is being ingested changes, it's not going to blow up the whole system. And now, so document database, if you're familiar with this, it's JSON data, so there's no rigid schema. I don't define the fields and the columns and the headers ahead of time. That does not mean you should just do whatever you want to, and hopefully you're going to see that as we go along today. I used to go to movie theaters on a regular basis, and last time not the last time, but years ago we went to see Wonder Woman, and my wife was getting a drink before we went into the theater, and I said I was going to take a picture of her and I'm going to put it in all my slide decks from that point on, because what she's demonstrating here is availability. So if you go to AMC, assuming they're still in business, they have multiple of those Coke Freestyle machines there, like a whole bank of them at some theaters. And as you can see here, one of those Coke machines is actually getting serviced right now. It's getting a refill of syrup, or maybe it's broken, or who knows. But because we have multiple, we have a cluster of Coke machines, it's still available for us. So my wife can still get the soda, and we don't have to wait for that machine to get refilled. And even better, the Coke maintenance person doesn't have to wait till 2 a.m. on a Sunday morning to go in and repair the machines. They can do it during normal business hours and not affect the customers. So that's a really good benefit of availability that distributed databases give you, and performance. So every database out there claims to have the best performance, of course. As you're going to see here, there are some access patterns where NoSQL can provide better performance. And a lot of these databases also take better advantage of memory. So memory is faster than disk, so that can improve performance. Every vendor, including my own, likes to throw out some what do you call them? Benchmarks. Sorry, it's a little late. I had a little bit too much apple juice, I think. But throw out benchmarks to show like the three bars in the histogram and say, oh, look, we're the best one, and the other two, they're chumps. Well, everybody publishes those same sort of histograms. So I like to focus more on the architecture, the reasons why it might be faster, and the specific design patterns where things can be faster. We talked about use cases already. This is just a list of them. This is Couchbase customers use cases, and there's lots of other ones. If you want to go check it out, couchbase.com/customers. But the first three on the left there, caching session, user profile, those are kind of the killer apps for NoSQL for document databases. And that's where a lot of people start with NoSQL. But as NoSQL has matured, it's gone beyond just that key and MapReduce access. The use cases have kept expanding and expanding. And you can see in the bottom right there, even finance is now on this list. There's lots of features that the larger, more conservative financial institutions have kind of been at arm's reach of NoSQL, but a lot of security features and ACID transactions and things have come to NoSQL. So finance is getting a lot more comfortable with it. And ultimately, this is just kind of a great quote about any sort of newer technology that you're not familiar with. It's not always better, but if you want to do something better, you got to be different. So I think that's just a good quote in general that can apply to NoSQL. All right, let's get into the modeling. We're going to start with a whiteboard exercise. This is one of my amazing drawings. No, not my son's drawing, not my daughter's drawing. It's one of my drawings. And so let's just imagine we're in a meeting and we're trying to whiteboard out some of our entities for our system. We're trying to model what we might need to store in the system. So let's just look at a customer first. And we're not even talking about the actual database implementation yet, the technology. We're just at the whiteboard figuring out, well, what do we need to know about a customer for this particular system? And so there's 4 things I want to point out here. There is a rich structure. So that's attributes and potentially sub-attributes. So we've got name, might be an attribute, or we might say first name and last name. Those are like sub-attributes. Day, month, year of a date of birth. We've got relationships and relationships to other pieces of data. So in this case, we've got some connections to other customers, perhaps. Maybe they're all on a family account for, I don't know, Disney Plus or something. So they're all kind of related. They're all kind of connected. We've got a value evolution. So maybe we start with the one purchase, but we can add more purchases as Helen keeps making more purchases of items there. And the last one is a structure evolution. So this is where, and this may not be something you know at the first stage, but maybe we start with, okay, our customer has a property of credit card number. And okay, that's fine. But in the future, maybe the requirement comes down that says, oh, we need to have multiple billing options. So now we have to evolve the structure of our data to handle 2 or more credit card numbers. Right? And now, if you're like me, and I know I am, this is exactly what's going on in my mind as I'm seeing this whiteboard exercise, because I've worked on relational for even now the majority of my career. And so this is immediately what I think of in my mind. So this is why I always like to start here, because this is familiar to most developers. So all those characteristics I just talked about, they're all here. So we have a rich structure. We have attributes, so columns in a customer table. We have relationships to other customers via the connections table there. So just a sort of a mapping table, if you're familiar with those. We have value evolution, which is just add another row to the table. What we have as well, but it's a little trickier, is a structure evolution. So again, just imagine, this is a rookie mistake, but imagine I put the credit card number as a column there in the customer table. And now we have to store multiple payment methods. So what do we have to do to support this? We have to add another table. And we have to create the schema for that table, create a foreign key constraint to customer. We have to sort of move the data from customer over to that billing table, remove those columns from the customer table. And that's a lot of work just for one relatively minor change. And I'm guessing most of you deal with schemas that are much larger than 5 tables, and looks like 4 constraints here. So schema changes can be a bit of a hurdle for the structure evolution. So now let's look how we would kind of do this in a JSON-based approach. And the thing with JSON is that there's multiple ways to approach it, and it's really going to depend on a lot of things. It's not a mechanical translation. We can't just say, oh, here's relational, okay, convert to NoSQL with a command line utility. It's not really that easy. But let's just start simple and see how it goes. So on the left is our relational database. On the right is our JSON data. So in this example here, it's pretty straightforward. It's just kind of this is a relatively mechanical translation from one row of data in a table to one piece of JSON data. And up there at the top there, you see document key. So it's not the same thing as a primary key, but it's a key that uniquely identifies that piece of data. So relatively easy translation there. We've got name, date of birth in a table, and a row in a table, and name, date of birth in a JSON document. All right? Everyone with me so far? I'm not seeing any sort of confusing, like a bunch of question marks in the chat, so that's good.
I just did have a question.
Sure.
You mentioned that the document key is not the same as a primary key. What's the difference, or what would be a difference there? Yeah,
I guess the difference is, I mean, you can think of them as kind of the same thing as a thought exercise. That's totally fine. But the difference would be that, a primary key is unique to a table, whereas a document key is kind of unique to that whole I'm going to say bucket of documents, right? So I might have I could have a primary key of 1 in customer, and I could have a primary key of 1 in invoices. Now, in a document database, I can't have 2 pieces of data that both have 1 as a key. So that's one difference. You can also, in relational, you can have sort of compound primary keys. Those are not super common, but with a document database, you can kind of simulate that, but it's really just 1 string for the key. Those are 2 that come off that kind of the main differences, but they're kind of analogous. So I wouldn't worry about that too much.
Okay.
Does that help? Okay,
yeah.
Cool. All right, so let's take a step further here. Let's go bring in the purchases table next. And so now we've got another table and another piece of data in our relational model. And you notice we've got customer ID, which is a foreign key that points back to that customer. So we know that this purchase corresponds to that customer. Now over on the JSON side, notice it's still just 1 document here. I don't have a separate document for the purchase. I'm embedding it into that customer document there. And so I can have an array in JSON. This is one of the kind of the main differences here is that I can, JSON is a little more expressive when it comes to richer data models, so arrays and nested objects and such. And so I don't have to have a foreign key inside of that purchase anymore because it's no longer foreign. It's now domestic. So you can kind of see here, this is not too much of a leap here, but we've gone from 2 tables and 2 pieces of data to 1 single document. All right. And so we can just add another record to purchase there. So now we've got 3 rows in 2 tables versus our, again, just still 1 document in JSON there. Just adding another item to the array. Okay. With me so far? Good. Okay, connections. This is where it can get a little complicated, and we'll talk about this some more later. But if we want to connect this customer to another customer, let's say there's a brother relationship, again, for Disney Plus or Hulu or whatever, we all have the same account, but we're all on the same subscription, but we all have different accounts. So I want to connect CBL 2015 to XYZ987, and that is my brother. And so I have another sort of mapping table that has a compound foreign key, I guess, in this case, of customer ID, or sorry, a compound primary key consisting of two foreign keys, those first 2 columns there. And now over in my JSON document, I can do, again, something very similar. I can have a connections array, and each one of those objects in that array can point to a different customer document. So I'm talking about this portion right here, where I say, okay, this is Jane Smith, but Jane Smith's father, you can go find him in a document with a key of SKR007. All right, with me so far? Now, kind of the crux of modeling here is determining when do I embed data and when do I point to other documents. That's really kind of the crux of it. So let's put it all together here. We've got the whole schema here on the left in relational world. And we've got an entire document there on the right, our JSON document. And this is kind of a comparison of the same data on both sides. So on the left side, we've got 4 tables, 7 rows of data, kind of all shredded up into pieces. And on the right side, we've got the 1 piece of JSON data. And normally you'd use a ORM, like Entity Framework and Hibernate or whatever, to kind of take the data from the left and put it together so it'll look like a C# object. That you could serialize into JSON just like this. So if we store our data as JSON, we can just deserialize it. I always get those backwards. Deserialize it directly into a C# POCO. We don't have to worry so much about the ORM mapping there. Now, one more point I wanted to make was about the structure evolution. So notice there I've made my rookie mistake. I've got card number, expiration, and card type as fields in my customer table. And the requirement comes down that says, hey, we need to support multiple methods of payment. So what we should do, right, is add card num2, expiry 2, and card type 2 to customer table, right? I'm sure you've seen that before, but absolutely not. We should not do that. We should create a separate table called billing and set up the foreign keys to point to that. I kind of went into that before. So we got to go through that whole restructuring of data. and moving that data over. Now, for a relatively small change with a relatively small amount of data, not a big deal. But if we're in the millions of records and our system is under pretty serious load, that's going to be tough to do. And we're back to the 2 a.m. Sunday morning fixing the Coke machines issue. Now, over here on the right, you can see I've got a similar refactor of my JSON there. I've got a billing array instead of just those root level attributes. But I want to point something out here. You might have, if you blinked, you might have missed this. The top right there, it's CBL 2015. And the top right here, it's CBL 2016. So we've got two different structures, two different models of data. They can both live in the same database. They can live together, even though they have different structures of data. Now, this is the point where some people are like, oh, that's pretty cool. I really like that. And some people are like, burn it with fire. That's terrible. And so what the question is, well, how do we actually deal with this? Because the database isn't going to enforce the structure of the data there. So the way you deal with this, first of all, if you think of this as completely a drawback, then maybe this is not the right choice for your use case. But if you think of this as, okay, now I have flexibility in the way I store my data, but I'm still concerned about the data being kind of inconsistent. How do I deal with different structures of data in there? So there's a couple approaches to this, and there's probably more than what I'm listing here, but these are the ones I've seen most commonly. Is we can start by introducing version numbers into our data. And so both documents can exist in the same database here. We've got two different users in this case. But I can now, in my code, I can say, okay, if version equals 1, then do this. If version equals 2, then do this. I could implement a strategy pattern, something like that. And version can be more than just a number if you want, right? It could be a .NET type name or an assembly name or whatever, however complicated you want to make it. But the key here is that both those can live side by side. I don't have to come in on Sunday at 2 a.m. to make that schema change. They can just live together. This is an approach you really can't take in a relational database because these both can't exist in relational. That you can't have name and version in one row and first name, last name, version in another row. They have to be the same rows and columns. So that's one approach, is version numbers. Second approach is, I'm going to call this the Big Bang migration. It's where we have all of our data in a certain format where everything is just name. And now I want to go in and I want to change all that data to break it out by first name and last name. Or maybe the reverse is true. I don't know, probably makes more sense to store name as just one string. But this is the situation where I just go and update everything. I go into my data and I update all the changes. So I'm not changing the schema. The data can still live like this, but I'm going to go in and update this in a series, or one big update or a series of batch updates. In some use cases, that might be fine. You can do this with relational too. It's a little more work with the schema, but you can do it that way. And the third approach, I didn't know these animations were in there. That's pretty cool. The third approach is, I'm going to call it cooperative migration, where this is a little more work, but it's actually pretty slick if you get it to work like this. It's let's just say there's a web application accesses a little piece of data in the course of normal operations. So I log in, it gets my user document. But while we're at it, let's go ahead and change this to the new format right there in my web application. And so as people log in and use the system, the data gets migrated to the new model gradually. So when it gets saved with first name and last name split out. Or again, probably would make sense to do it the other way. But you can kind of take this approach with relational. I've seen this before. But it gets messy because you end up with like a name, first name, and last name column all in the same table and a lot of nulls. I'm sure no one's ever seen that before. In a document database, you don't need a bunch of those nulls hanging around. You can kind of split that name into first name, last name, and then ditch the name field on like a per document basis. So these are three approaches that I've seen before. You can use any one of these, you can use none of them, or you can use all of them together. And if you know of a better approach, I don't know about it, I'd love to hear about it as well, because it's just there's just lots of different ways you can sort of tackle this this issue. Okay, and now before we get into the next section, I want to just take a quick break here and say there's some tools to help you with data modeling as well in NoSQL. So this is a list of some tools that I've seen used for NoSQL before. So Hackolade is a relatively new startup that supports a bunch of them. So Couchbase, Mongo, Elastic, Cassandra, Dynamo, and then Firebase or Firestore, whatever they're calling it these days. Irwin's NoSQL tool, I believe, supports just Mongo and Couchbase right now. Could be wrong about that, but I think that's what it supports. And Idera's, I think, just supports Mongo. There's also this free online tool that is useful sometimes called JSON Editor Online. And it's kind of a bare bones offering that can help you with modeling and diffing and cool stuff like that. So those are some tools I recommend checking out so that you don't feel like you're completely on your own out there just trying to wrestle with JSON. These tools are great because it helps you kind of collaborate with your team as well on the model. Okay, so let me take a quick break here and see if there's any more questions.
I was going to say, it was kind of interesting. You introduced something when you were naming your keys, and you used kind of the name user to kind of define what type it was, because I remember you said that the bucket can have anything in it. And then the question from a relational standpoint would be, well, how do I know what I'm getting out of it? How do I know what I'm looking for? What is the strategy you like to use for that?
Yes, we'll definitely talk about that here in the next section for sure. Really good question. Yeah, I kind of jumped ahead a little bit with the user : and then long number. That's definitely a strategy you can use for a key value lookup, is to give it some meaning. So with that in mind, why don't I just start talking about accessing data? And so we kind of unless there's another question, I'm sorry.
Yeah, real quick. I mean, I hate to go into it big time, but you mentioned Mongo and Couchbase and several others. Where's the differentiation? Are they sort of the same like MySQL and SQL Server, or are they trying to be different, or how are they different?
Yes. I mean, I have some slides for that at the very end. If you want me to skip ahead right now, or just wait till the end.
I can wait. No problem.
Okay. All right. Because that's a very common question I get all the time. So really good. Was there someone else had a question?
Yeah, you had mentioned another strategy, and one thing that we've done in the past is associating a JSON schema with usually by some schema name and version, and then you can do a transform from version to version. So if you have an old document sitting around that hasn't been transformed, you can just knock it forward until it reaches the current top version.
Okay, and so that's an approach that it's kind of like what I was getting at here, except that instead of integer, you have a full-on JSON schema they're using for transform, which actually makes a lot more sense. So. And
you can store that just the same as every other JSON document.
Sure. Okay, yes, very good. I'm going to make a note of that actually. Let's make a little note here. JSON schema store as stuff. Okay, cool. I like to just sort of tweak this presentation as I go along and learn new stuff and research. So thank you for that. Okay, was there any more? It's hard to see when I just have like 4 windows at a time. Oh wait, I can expand that window a little bit. I can see more faces now. All right, that's pretty cool. Okay, it's almost like I'm actually in the room. All right, accessing data. So the way you plan to get data out can also affect the way you model your data. And this is important to think about, especially with the JSON model, because with a relational model, we're always thinking about third normal form. It's got to be in third normal form, and that's pretty much the guiding principle. And sometimes we can go into higher normal forms, but the way we model data is third normal form, pretty much all the time, because that's the most efficient way to store it, and relational databases are good at that. But if we can put that constraint aside for a second, there's lots of other ways we can access data beyond just the normal third normal form design approach. So let's start with a key value here. And this is just to reiterate on what key value is. So if you know the key already, it's really, really simple and extremely fast to get that piece of data. So oftentimes, I know when I work with relational, we try as much as we could to avoid accessing the database when possible, or to consolidate it down to one query, every page load or something, as much as we could, because data access could have a really big impact. It was the bottleneck. But if we're talking NoSQL and talking key value lookups, it's super, super fast, like microsecond fast. So if you can use key value, even if you have to jump through a few extra hoops, it's going to be really, really fast. So this is just a really small C# example. This is Couchbase specifically, but kind of the same idea with other databases. You have a key, you look up that key from a collection, and then you can parse it into a POCO or whatever. And same thing if you're inserting, you can just insert, specify a key, give it a POCO. It's going to serialize that. Serialize? Yes, serialize to JSON and store the JSON in the database. I don't have to write any selects or inserts. I'm just using the key value API directly. And so back to Garo's question kind of about how to design keys. So if we want to stick to key value lookup as much as possible, and if we care about performance, this is something we want to do, it's going to benefit us to think about our key design. So this is some of the things that we can do to design those keys to be a little more useful. So we can use a natural key. Maybe like a VIN number or an email address. In some systems, an email address might work, or a driver's license number, something like that might be a good natural key. Making a human readable key, as kind of I did earlier, where it was user and then colon and then some identifier number. So I can at a glance see, well, I know that's a user document just by looking at it. Deterministic, I'm going to tell you what I mean by that in the next slide. And all these things together will make your key semantic, make it meaningful. We could just throw GUIDs in there if we wanted to, and sometimes that's totally fine. But if we can, giving it a more meaningful key is going to lead to some benefits. So here's an example, and this is an imaginary blog site that I've created, and it's running on Couchbase. And I can design my keys in such a way where I can just walk through all the pieces of data that I need with key value lookups. So my first thing to do is log into the blog site. I'm an author, so I'm going to log into the back end. My username is Matt. My password is whatever. It's going to go to author : Matt. That's a key value lookup. Seed is my password match. Okay, log him in. Once he's logged in, okay, now I'm going to go to my list of blogs page, and I can look that up by author : username : blogs. And that's a list of all the slugs or titles or IDs or whatever in that document. And then from there, I can click on one of them, and I'm going to edit the C#9 features. And so I go to blog : C#9 features, and that's where all the content of my blog is. And I can edit that and save that one document. And then maybe we have a comments document that hopefully everyone's ignoring, but that can be one that people can, as they add comments, we can add those to an array in that document or whatever. And we can just look that up by just appending : comments right to that key value. So starting from just Matt, we can walk through that whole chain of documents and look up all that data with just key value access. No selects weren't necessary, no SQL, anything like that was necessary to walk through that chain of documents. So if we can structure our data in such a way to do this, it can be really, really fast. So let's get into some rules of thumb here. So I've talked a lot about modeling. These are kind of some of the rules of thumb that I think if you're modeling data in JSON, this is a good place to start. It's not always going to be the right fit, but it's a good place to start. So if you have a relationship in your data that's one-to-one or one-to-many, so much like our purchases there, we have one customer and many purchases. It makes sense to store those as nested objects. So an array called purchases there. Conversely, if we have a many-to-one or many-to-many relationship, so our customer Jane Smith has connections to other customers, we're going to store those as separate documents, and we just have the keys to look them up when we need to. And intuitively, this makes sense as well, because if we're going to embed a customer inside of a customer, well, then that's just going to be a Matryoshka doll, and it's going to be n+1. It's going to be, embedded all the way down. Turtles all the way down, as they say, right? So that's just not going to work intuitively. So that's kind of where to start. Now, when we're talking about reading data back out, this can also affect the way we model it. So if our reads are mostly going to be in those parent fields, like we're not going to necessarily go to the connections of a customer more often than we will the customer's actual data, then we're going to store those children as separate documents. And again, this intuitively makes sense, the n+1 problem. If we're going to read parent and child fields together and often, so maybe a shopping cart or purchases list here, it makes sense to store them as nested, because this is now one operation to get all that data, one get. And you can see where this is going. If the rights are mostly parent or child, so not both together, store them separately, because we can now modify them separately when we need to. Again, very, very fast. And if it's the the writes are mostly parent and child together, nest them together. So we can kind of batch those all up into one write or one update operation. And so here's the where you want to hit print screen if you want to take notes here. The easy way to take notes is these days just hit print screen and save this to your desktop. And if you're like me, you've got a whole messy desktop of print screens that I'll never get to. So, but basically, what types of relationships are being modeled and how are the relationships accessed? Those are the two main questions there with modeling. Okay. So up until now, I've basically talked nothing about, I've talked only about key value access. So documents, I can look them up by key, I can get the JSON value. What's the best way to do that? Now, fortunately for us, NoSQL has changed and evolved a lot since those early days. And now there are lots of ways to access data in NoSQL databases, in document databases, is what I'm mainly talking about. So this is just a little graphic of other ways to access data in Couchbase. For the most part, there's some analogs to these in other NoSQL databases. So almost always the key value is going to be there, and that's the very fastest way to get data. Notice it's a direct line right to that blue document square. Nothing gets in the way. You can just go and get those key value lookups super, super fast. Unfortunately, we can't always deal in key value lookups. We have to sometimes query on other attributes besides the key. This is where something like a SQL query would be very helpful. And I know what you're saying. SQL in a NoSQL database? How can this be? This is one of those differentiators that I think John was asking about, is Couchbase specifically has a full SQL language to query your JSON data, including joins, including insert, update, delete, all that good stuff is there. But as you notice here from this little diagram, there's that indexes that kind of gets between the SQL query and the data. So we have to now go through a query parser, index lookups to query the document data. So this is not going to be as fast as key value lookup, but it's going to be way more flexible. And it's still going to be pretty fast. And then another interesting thing you can do is a full text search. So how many of you, and don't have to raise your hands, because I can only see about 9 of you right now, how many of you have ever implemented a full text search by using a like and percent signs? I know I've tried it a few times and it always ended badly. So the right way to do that is to use a full text search engine instead. So if you've heard of like Elastic or Solar, things like that, that's another way you can access that data. But again, we've got a different type of indexes there to have to sort through. So it's still not going to be as fast as key value. But again, if all we have to go on is the search terms, we really can't put all the search terms in the key and do a key value lookup. I mean, I guess we could, but it would be a lot of work. And there's some other things I talked about MapReduce early on. That's kind of a remnant of the early days. Analytics, I'm not going to get into that today. But as you can see, these all are different access methods that access the same pool of documents. So I want to talk about a few of these going forward and how those might affect your modeling as well. So one of the things that wasn't on that last screen, but I think is worth talking about, is something called subdocument access. So early on, I talked about taking all this data and sort of consolidating it into a single JSON document. Well, if you're, maybe you thought about this and you thought, well, okay, that's kind of good, but then I have this huge piece of JSON I've got to send back and forth over the wire. Yeah, fair enough. So unless your database has something called subdocument access, which is where I say, I'm only interested in just updating the address here. So just give me that address part. I'll update that and send just that address part back over the wire. Not the whole profile, just the address part. Well, that's what a subdocument access can give you. And I don't know if all the NoSQL databases call this subdocument access or not, but a lot of them have this. Couchbase calls it subdocument, so that's what I'm going with. I think Firebase or Firestore has something, and it's a little different, but they have something like subdocument access as well. So this can also change the way you model, because now it's not as big of a deal if we have a huge piece of JSON, because I can just send the parts I need back and forth. Okay, I mentioned SQL for NoSQL, which is, crazy paradox, but it's the thing I love most about Couchbase, because I'm a big time SQL Server user from way back. And I've always been interested in NoSQL, but I always have liked, the language of SQL itself. So Couchbase has kind of the best of both worlds. So here's a few examples of, these are queries that I can run against JSON data. And there might be a few things that look different than your standard, Transact SQL, but it's very much a standard SQL type of language. So here I'm getting all the users with a Visa or MasterCard. I can't really do that with a key value lookup, but I can do it here with just a where and an or. So again, this is a really handy way to query data, but it does have to go through some indexing. And so that's why it's important to understand your query plan, and probably even more so than in your standard relational database. So here's an example of a query. This is a Couchbase SQL query. I execute this, and it runs in 1.2 seconds. Does that time show up on the slide? It doesn't. Let's just say it runs in 1.2 seconds. All right, it's using an index here on the type field. So that second green box from the right is saying I'm using the type index. So I've indexed the type field in my JSON, just like you can index a column in SQL Server. And this is the visualization that shows which parts of that query are taking the most time. So we can see that the fetch part there in the middle, the orange part, is taking up about 98% of our query is actually fetching the data. Makes sense? So we can actually have a little query advisor come up, just like SQL Server, and say, here's a better index. You might want to try this one instead. This will be a little faster. And if we wanted to, we can even create a covering index, which I don't want to get too database nerdy here, but we can actually chop out that whole fetch step if we want to take away that star, for instance, on line 1 and say, we just want, these 5 fields. And we can index those 5 fields in a covering index. We can even skip the fetch step then and just get the data right from the index. So
quick comment, Matt. So we got a question about the subdocument access. Is there a performance penalty for that, or is that?
So in Couchbase land, I can say no. There's no performance penalty for that at all. It's the only penalty is you gotta write code that specifically identifies which part of the document you want to pull out. That's the only penalty. In fact, I'd say it's a performance gain, right? Because you have less data to send over the wire. It's a little more work, I guess, because you have to identify that part, but
Seems like it aligns with what you're doing here, though, with your query plan. Like if you reduce the amount of data you're bringing across from the database, different techniques to do that, it should, in theory, improve your performance.
Absolutely. Yes, absolutely. That's true of any database, right? And that's true of Couchbase as well. And so all these tools like recommending indexes and someone's trying to annotate here. Is that something that's normally allowed? Should I go ahead and improve that? You don't see this, but I'm seeing an annotation request from Fred Samank.
Nope, I don't see it.
Okay, I'll go ahead and prove it and see what happens here. Hopefully this doesn't draw something offensive. That's pretty cool though. Anyway, yeah, so covering index will then reduce it even further. Of course, that increases your index size. So you have to think about that, like always the standard index trade-off type of thing. Well, it doesn't look like Fred's drawing anything, so I'm going to shut this down, I guess. You can leave a comment there, Fred. I'm happy to revisit. The next one is full text search. So this is a search that revolves around text. So again, don't want to get too nerdy here, but if you've heard of things like stemming, language awareness, facets, and ranking, this is where all that stuff comes into play. Just to make it kind of simpler, I'm doing a search for the keyword submarine here. And I get the results back, and it's going to identify pieces of text that have the keyword submarine in it. And so this is also going to be ranked. So results that have submarine mentioned more than one time are going to rank higher. So kind of like a Google search engine sort of thing. And it's language aware. So if there's a plural version in there, submarines or sub-marine, it's going to be able to find those as well intelligently. And that's kind of stuff you can't do with a like. Okay, so again, here's the cheat sheet. Hit the print screen, and this is kind of the way I think about it. And there's other ways to access data beyond just these 3, but these are kind of the 3 main ones. So always go to key value if you can. It's going to be super fast. Go to full text if you have a text-based search. If you're providing like a catalog search to your customer or a keyword search, and then Nickel is going to give you everything else. A SQL query is going to give you the flexibility to query anything else, but of course you need really good indexing there. Also, just for Couchbase, one of the newer things we offer is you can combine a SQL query and a full text search, which is pretty darn cool. I think. Okay. All right. So I'm taking another sip here as I pause and see if anyone else has any questions.
Have you been using DynamoDB at all? Because I started learning it, and I find that it's very particular about what types of queries you can do. And so there's table scans and there's key lookups.
Yep.
I mean, are other NoSQL databases similar, like in the ways that you deal with data access?
So I'm not a Dynamo expert. I haven't used it that much. I do know that indexing on Dynamo historically, I don't keep up on it too much, but I think your indexing is limited to maybe even just like one field or something like that. And I could be wrong about that, so don't take my word for that. You'll look it up. But yeah, it can be tricky with the indexing there. I know with some people ask me this. They're like, how many fields can I index with Couchbase? And I'm like, well, how many fields do you have? I mean, there's not really a limit there. I'm pretty sure with Mongo, you can also create very similar indexes. Mongo doesn't have the SQL syntax, the SQL language. It's got its own sort of Mongo query language. But I think indexing is similar there. And CosmosDB is another offering that you're probably most familiar with. And indexing there is similar to what you're seeing with Couchbase. And they actually have a SQL syntax there as well in Cosmos, which is pretty cool. It is a limited version of SQL, very limited. No joins, no update, insert, delete. They just recently got group by, so that's good. That's nice to see. But it's indexing there is also, I think there's no limit on indexes, although they do have the whole thing with the what do they call them? The various different not called regions, but they're called shards. I can't remember. I don't know, but there's an extra wrinkle in Cosmos. You have to divide your data up by different sort of groups.
For free text search, how much control do you have over the way indexes are done? Can you do things like synonyms and set up like indexing pipelines like you can with like Elastic or something that's built for?
Right. So I would say with full text search in general, Couchbase has, and I'm not much of an expert on this, but Couchbase has some additional custom sort of, I forget what they call them, filters or functions you can add in there. And I think synonyms is one thing you could probably build in if you wanted to. It's not something that has support for. You'd have to build a function for it. I would say in general, if you have a really, really deep, complicated text search use case, probably Elastic's going to be better at it. And I know the salespeople on the line are probably like, I can't believe you're saying that. But it's true. That's just true. And Couchbase has a good full text search engine and it's getting better. And many customers, it's totally adequate. They don't have really deep text search use cases. They're not creating DuckDuckGo or Google. They just want people to be able to search their catalogs. And so that's totally fine. And of course, worst case, Couchbase also has and creates an official Elastic connector. So if you want to use them both together, totally do that. Was there one more I think someone was trying to ask?
Yes. Is the query analyzer, I'm assuming that came from CouchDB, is that common amongst the other NoSQL style databases?
So CouchDB and Couchbase are not the same thing.
Okay.
So the query analyzer is something that came just from Couchbase. And that's a question I have a slide for later as well. Query analyzers elsewhere. So at the very least, anything with indexing is going to have a way to explain the query plan. Now, whether it's a visual way or if it's just like a sort of a raw data readout, there's going to be something to explain that query plan to you. Yes. Okay. All right. So migrating data. Are we doing okay on time here, Garo? Is that okay? So people often ask me about how do I migrate from database X to Couchbase, and my question is often, I don't want to focus on the how too much. I want to focus on the why first before we talk about tools. Why do you want to migrate from X to Couchbase? Because sometimes it might be the case you don't want to migrate. You really just want to sync the data between them, or you just want to be able to copy some data over to try it out, right? So just make sure you know why you want to migrate data over before you actually dive into the tooling and stuff. So, you got to think about this, sort of break down the problem. Another one of my amazing drawings here. We have multiple sources of data, we have like a DB2 and a SQL Server and an Oracle database on the left, and we want to kind of combine those together, one or more of them together, and put them into another database like Couchbase. This is the kind of time where you got to ask those questions like, are we going to clean the data up as we move it over? Are we going to enrich it, combine it as we move it over? We're just going to do a straight up migration, like just raw copy from here to there. And I'm going to use the term migration here to mean both synchronization and we're going to move our project from database X to database Y. In my mind, it's kind of the same thing because it's not always just one big bang copy and paste the data. It's often an ongoing process in production. So I'm going to talk about those as if they're the same thing going forward. So yeah, you might want to move it over to Couchbase for your use case, for instance. Maybe you think it's a better fit for it, or you just want to do a proof of concept, something like that. So there's some tools for this, just first of all. So you may have access to some of these already at your enterprises. So tools I've pictured here with the logos. There's also tools like Dart. There's some ODBC connectors you can use a little lower level than that. Debezium makes some connectors depending on which database you're using. Make some Kafka connectors as well. NiFi is one of my favorites. If you never used that before, that's such a cool visual tool for moving data around your enterprise. Very cool. Cincinnati Reds are actually using that, and I got to work with them, and that was a lot of fun. I just learned about this tool called GlueSync today. Apparently, it's been around for a while, but it's a tool I learned about today at our Couchbase conference, which can sync data between SQL Server and Couchbase. Very cool. And CData makes some of the ODBC drivers for a lot of different companies. So if you have one of these tools already, if you're familiar with these, this might be a good place for you to start. You can also build your own kind of script or migration tool. So Python's used a lot for this, or just bash scripting. NoSQL databases will usually have an imports command line tool at the very least. So like CB imports for Couchbase can import data from CSV or JSON. Mongo import, same thing for Mongo. SQL Server has SSIS, or heaven forbid if you're still using DTS. I don't know. Anybody still using DTS? Represent. Spent a lot of time in DTS back in the day. Or if you're in Oracle, then you can use something like Golden Gate if you wanted to move data around. Those are some other options that kind of build your own. The way I think about this is just kind of keep it simple as much as possible. So one approach you can take is, here's my relational data. I can export that to CSV. There's lots of tools to do that. And then I can import them with the command line tool right into a NoSQL database. I'm going to call this the kind of the raw data, right? So it's still in relational form, but it's just in JSON format instead. And so you can often just do that, just go right into place, especially because with Couchbase, you've got SQL with all the joins and things that you can just keep on trucking that very same way. And I wouldn't say leave it like that, because you're going to have lots of joins, lots of pieces of data everywhere. And so you can start to transform that data, maybe just like one entity at a time, into the more optimized, consolidated JSON version of it. Reduce the need for joins, which is going to improve your performance, or maybe even reduce your need for using SQL, and you can go to a key value access instead. So maybe it's just one at a time. You start with the user model, for instance, and then that's where it's the slowest, and we'll go and we'll work that over. Then we'll go work on the invoices part of it or something like that instead. And so then this first bucket kind of becomes like a staging area. So it goes into there, just the raw data in the staging bucket, and we have some transformations that will put it into the more optimized JSON model like we discussed earlier today. This is super easy with if you have a SQL language like Couchbase, especially if you're coming from an organization that has lots of SQL knowledge, because it's the same language, basically. And align it with your data model. So think about your data model first, right? The modeling step is very important. If you want to take that big step, not just copy the data over, copy and paste, but actually make JSON work for you, is align it up. And until you do that, you're not going to see the advantages of using JSON. So in the long run, don't treat JSON database as if it were a relational database. That's kind of the one sentence version of this presentation. And then in the process of doing it, plan for failure. This is true of, I've done lots of migrations in my day, and I started out thinking, this is going to work perfect the first time. Nope, it never does. So plan for failure. Plan for your source data to be, old, junky data that never got cleaned up. It's still going to be in there. It's going to throw your code for a loop. Hardware failure. A server could crash right in the middle of your process. It happens. And resource limitations. This is one that's bitten me before in the past. Is I'll do like a proof of concept. We'll migrate 1,000 records over. We'll get that working. Bam, it's great. Now let's do it. Let's do the full version of it. Let's do all 10 million records. And wait a second, I was using way too much RAM. It's out of memory error or Stack Overflow or whatever. And I got to go back and think about that. So don't think of it as a one and done type process. It's an ongoing thing that maybe even DevOps needs to monitor that and manage that in a production environment. But that's the thing with migration. You got to make sure you have a good reason to do it. I want to see you use Couchbase or NoSQL at your company, your next project. But if it's the wrong use case and it's going to turn you sour on NoSQL, I don't want that. That's even worse than not using NoSQL at all. So make sure you have the right use case for it. And ultimately, we want our migration process to be super boring. We want it to be predictable. We want it to be logged, and we can restart it. And that's what we want to happen in the end. Here's a few examples of types of just sort of the details of how a replication might work. So maybe we go from Couchbase to Relational. Couchbase has a protocol called DCP. All the changes that happen in Couchbase get published out to the stream called DCP. Kafka, there's a Kafka source for Couchbase you can use to consume those and then put them into a sink for a relational database to pick up, or vice versa. Couchbase also can act as a sink, and Relational can go into that. If you're doing something like SQL Server with SSIS, you can publish to an SSIS task. CData has some drivers for this. So Relational can go through SSIS and publish a task, which can then be consumed by Couchbase. And of course, we can always make it part of our application directly. This is the last resort, I would say, because this may or may not be reusable, and it's a lot of work. So make sure you got a good reason to do this. A good reason might be to reduce the impact on your end users during the process, or maybe do some A/B testing, do a proof of concept, things like that. But this is not where I suggest you start, of all things. All right, I just have a few more wrap-up slides, but I'll pause for another sip and some more questions if you got them. Let's see, in Couchbase is a link syntax. What happens if you specify a column in the select clause that does only exist in some version of the entity? Okay, so I haven't even touched on link yet. Couchbase does have a link provider, by the way, but if we're talking select syntax, what happens is, I can actually show you what happens, but it's going to be missing. It's not going to be there. So I can actually show a quick demo of that if you like. Let me see if I can bring it up here. If you don't mind, we got time for this. So I've got, let's see. This is Couchbase, by the way. Hello, everyone. Couchbase, everyone. Let's bring in some travel sample data here. I like using travel sample because it reminds me of what the world used to be like. So I'm just going to load up some documents here. This is a pretty big list of documents. It's taking too long. Should have loaded this beforehand. Okay, well, we're almost done. 18,000 and 31. There we go. Okay. So let's do a quick refresh here. And okay, select, let's do from, probably can't see that. Let me zoom in a little bit here. Travel sample R, where r.type equals route. And, whoops, that's not going to be good. That's going to return way too many. Limit 10. Okay. So you can see here I've got, we'll put it in table format. No, that's not going to be good. JSON format here at the bottom, you can see I've got a route that has airline ID, schedule, number of stops, etc. Okay, so your question was, what happens if I select a column that's not there, basically? So airline ID, r.equipment. All right, so we've got those three. Now we can look in table format. We've got those three values there, right? Like a typo, for instance. What if I said airlin instead? Okay, it's not there. It's just missing. It's not a null. It's not an error, anything like that. It's just missing. Now, if you're here in the query editor, you get a little warning that says, hey, maybe you misspelled something, because it can actually look at a sample of the data and say, that's valid SQL, but I don't see an airlin anywhere in the data. So you may want to look at that. And one other thing I should mention is there's a keyword in here. I have a whole session on nickel, by the way, but we're not going to get into it here. But airlin is missing. So maybe we want that field to be there. We want there to be an airlin. We want to identify documents where there is no airlin. Okay, execute, and it returns 10 docs. Not terribly interesting, but it's going to find those because there is no airlin field there. So we have this is missing syntax that's not in your regular SQL, because the concept of missing doesn't exist in regular relational SQL. Okay. Any more? Last call for Raspberry Pi raffle. Get those in there. Okay, they say you only remember about 3 or 4 things from any given presentation, so here they are. First thing, pick the right application. So if you have a microservices architecture, you have an SOA system, or a use case that would be really good for Couchbase, that's where I would suggest you start. Try out a proof of concept there would be the next thing. Focus on the modeling. Have yourself a narrow focus of your proof of concept so you can just get to a result as soon as possible. And use that time to review your architecture and say, is this going to work for us? Do we have to revisit some part of this? And use a tool like Hackolade or Irwin or something to actually work on those models and do it collaboratively and rigorously. Spend a lot of time talking about matching the data access to the requirements. So key values fast, yes, but it's not always the right tool for the job. So use whatever access method makes sense and works with your model. A couple of blog posts for you. I did a proof of concept blog post there. You can check that out. These are kind of older posts, but I think they still hold up. They're sort of evergreen, I guess. I like to think so. I wrote them. So the first one's about proof of concept, moving from relational, if you want to go through that process. The second one is about JSON data modeling. It's a lot more sort of into the weeds of the mechanics of it. If you want to check out that blog post there, it kind of goes through that whole CSV export, staging, combining data into JSON process. This is my wonderful family back when we could go on cruises. One of our favorite things to do, by the way. And my enormous head there barely fits in the picture. But you can find me on Twitter, mgroves. And I'm also on Twitch. I haven't been much on Twitch lately. I've been very busy, but I go on Twitch usually twice a week. It's not like it's not this sort of thing where I'm showing slides. It's just kind of a hangout and code, answer questions, work on stuff. And it's just sort of a fun hangout. And if you have questions about Couchbase, go to Couchbase, technical questions mainly. Go to forums.couchbase.com. There's a .NET section there. There's a server section there, a mobile section, all that kind of good stuff. And one more quick plug here before I get to the last question slide is Couchbase Connect. It's going on right now. Today was day 2 of it, and there's still 1 day left, and it's totally free to sign up. So if you want, and you can get the earlier sessions on demand on video right now. There's 12 sessions about data modeling, tagged with data modeling, by the way. So if you want to explore data modeling more, maybe you're sick of data modeling, you can explore other topics on Couchbase there. And by the way, these sessions are not just Couchbase marketing propaganda. These are customers and community members. They're speaking and presenting, how they're using Couchbase, their lessons learned, their challenges and techniques, including one of my favorites, which was on today, Domino's Pizza. That was some good stuff, very tasty. As Garo said multiple times, I think he used the word delicious to describe things, but Domino's, very delicious. All right, so if you use that link down there at the bottom, bit.ly/connect register, that's actually my custom link, and I get a free pizza for every one of you that sign up using that link. Free Domino's pizza. No, not really. I wish I did. That would be great.
It's a lot of pizza. Can you eat that much pizza?
I used to work at my parents owned a pizza shop, and I worked there, and I did everything, and I loved it because it would just be free pizza like every day. Loved it. So
from there into a career in software was a very natural progression.
You say that because it actually was, because one of the first things I did when I got there was we're taking all these pizza orders by hand on a notepad, and handwriting is terrible. And I'm just like, why don't we bring over like an old IBM PC? I'll write a QuickBASIC program. We can start taking orders that way. And there you go. My very first piece of software deployed to production, written in QuickBASIC for a pizza shop. So these are my frequently asked questions. I get these asked all the time. The number 3 one there, I don't get asked as much when I'm sitting in front of a camera, but I am actually 6'5.5", very tall, but I'm terrible at basketball. So there you go. But I think there were some of these questions that people brought up during the session. So I'll click on one of them if you like. I can do the different than Mongo one. I think that was what John was asking, right? Okay. So there are a lot of differences, right? But these are kind of the big ones, I think, that sort of differentiate Couchbase and Mongo. So they're both JSON NoSQL databases. Yes, that is true. The architecture, I think, is very, very different between Mongo and Couchbase. Couchbase has a memory-first architecture, which means that all the data goes into like a built-in cache layer, basically. So you don't need to put Redis on top of Couchbase. You don't need to put any sort of caching on top of Couchbase like you would with Mongo, potentially. And that can just add a boost right there. It's got what's called a master-master architecture, or I think maybe it's more correct to say like a shared nothing architecture these days. You might see both of those listed, so that's why I put that term in there. But that basically means that every node in a Couchbase, back to that earlier diagram with all the different cylinders, every one of those nodes in Couchbase can perform reads and writes. Whereas Mongo has like the sort of I think they call it primary, secondary these days. It used to be called, and I apologize for saying this, but it used to be called master slave. So you might see that listed in some of the documentation, but primary, secondary, where everything goes to the primary, it's kind of like the bottleneck, and the secondaries are only sort of swapped in if the primary goes down. And then auto sharding. This is a really terrific feature that you won't even care about until it's gone, because when you have distributed data, all those different machines, sharding is the process of deciding where do I put the data on those machines, and Couchbase is completely automatic. With Mongo and other systems, you might have to define, like, oh, I want to shard this section of data over here and this section of data over there, and now you got to worry about hotspots and balancing, all kinds of stuff. And Couchbase is completely automatic. Those are architectural things that will almost surely be differences in perpetuity. The other things at the bottom there, features, these are things that I've changed these bullet points over the years because, Mongo's added stuff and Couchbase has changed things up. But I mentioned SQL. That's a huge one for me. I don't see Mongo doing that anytime soon, but it's always possible. You can write SQL queries, full SQL, like no joke, joins, unions, common table expressions, everything on a Couchbase SQL. Built-in full text search. Mongo has a text search. It's not super great. Couchbase's full text search is great. It's built on an open source project called Bleve, B-L-E-V-E. Really cool. Analytics is something that Couchbase Enterprise has, which if you are in analytics or in reporting, you often have to worry about things like data warehousing and ETLs and things like that. With Couchbase, you can have the analytics nodes live in the same cluster, updating data in real time. Super great. You don't have to worry about your data being 24 hours old, things like that, for instance. So those are a few of the things. There's also some differences in the way mobile works in Couchbase, and I'm sure there's a few other things that are out there as well. But those are the ones that stick out to me the most. Anything else on here look interesting? Want me to click on it?
I was curious about the Couchbase licensing.
Yeah, this is probably something where I'd want to hand it over to our more sales-oriented people. But we do have a community edition, which is totally free to use in production if you want to. And you can't buy support for it from Couchbase Incorporated, but you can get forum support, Stack Overflow, things like that. And this is actually, the second bullet point is no longer true, I think. The binary release is pretty much now at the same time as Enterprise. So this is
within
an
a
old
month
one.
or so.
Well, okay. I think it's very, very close. It used to be a much larger delay. Enterprise, there are some features that are not available in community there. So analytics, I just mentioned that before. Things like rack zone awareness, multidimensional scaling. Those are all very fancy, cool sounding things. Those are available Enterprise only. It is, however, free for you to download, and you can try it out and use it as long as you want to in dev, test, QA, non-production environments, I should say. And you don't need to buy a license to do that. But if you do want to go to production, you can actually buy support from Couchbase as well. So features, support, and production licensing are kind of the three main points that I'll cover there. And like I said, the other people here probably know the story much better than I do.
Yeah, certainly if there's more questions, we can help.
Yeah.
I've got maybe a different question altogether. I know you mentioned it briefly, like why choosing what's the right application for NoSQL versus not?
Mm-hmm.
What's your rule of thumb on that?
Yeah, I mean, I guess, there's a couple different things I would look at. Those three or four things I mentioned at the beginning, where it was the main concern was scaling, flexibility, performance. Those are kind of the big three. And if your application, those aren't a concern for your application, then, it may not be the right fit. If it's a really, really small scale application, Couchbase will work for it, but I don't know it's necessarily going to give you any benefit over, say, SQLite, for instance, or MySQL, something like that. And flexibility. So if you're in a use case where you want to have a flexible JSON model, where things like IoT and Customer 360, user profile, things like that, where you can really benefit from JSON, or at least benefit from not having to worry about changing your schema all the time, or having to do all kinds of schema, gymnastics. That might be a good fit for it as well. I will say that, I showed this slide a while back. This was the very beginning. It was on all the use cases. Now, I've been at Couchbase for 4 years, just over 4 years as a developer advocate. And people ask me this all the time. And it's probably at the very beginning, isn't it? What use cases did Couchbase cover? Here we go. Now, this is a list that I've seen grow over the years in surprising ways. So, like I mentioned, finance. There were no ACID transactions. There was some auditing things that Couchbase couldn't handle, and different organization in terms of multi-tenancy, things like that. That Couchbase has now added all those features. Even the SQL query language I've mentioned has kept evolving and getting better and better. Joins are a lot more flexible than they used to be, and indexing is a lot more powerful than it used to be. And so, the use cases for this just keep growing and growing. So if you have something in mind, something I could certainly, people ask me all the time, hey, could I use Couchbase for this? Could I use Couchbase for this? Well, yeah, probably. There is one use case that I say almost across the board, probably don't want to use Couchbase for it. So sometimes people ask me, can I use Couchbase to store files? Is it a good place to store files? And I'll say, you can do it. We have customers who do it. I wouldn't recommend it, especially larger files. It's just not really a good file storage database, I guess. So
just base64 encode your files and images and just.
I mean, that's what they do. You can certainly do that, and we have customers that do it. The problem is, one of the problems is that you're limited to size. The Couchbase document is 20 megabyte limit. So if your files are bigger than that, now you got to split them up, and there's a whole thing there. And if you do that, now you could have one part on a node 1 and one part on node 10, and now that's just going to be a whole lot of extra overhead to bring those together into one piece before you decode them. So
cool.
Yeah, right. That's what I would say.
We're at 8 o'clock now, so thank you, Couchbase, for sponsoring the meeting. Thank you, Matthew, for your great presentation. You want to put your contact slide up in case people want to get a hold of you. They can find you on all of the different places. And, you know, we can, recording will be available. We'll send the link out on Meetup on the comments, and you should get notified if you're on the message. And that's all I got, man. Thank you guys very much for coming out, and we'll see you next month.
Thanks, everybody.
Thank you.
So much.
Much appreciated.